Welcome to The Explainer. I am so thrilled you're joining us today because we're looking at one of the most fascinating absolute life-or-death puzzles in human history. I mean, think about it. Today, we take navigation totally for granted, right? A network of orbiting satellites can literally nail down your exact position down to a few feet in a matter of seconds. But I want you to imagine a time when the world's greatest navies became hopelessly, dangerously lost the very moment they lost sight of land. Pinpointing longitude wasn't just some abstract math puzzle. It was a massive global crisis that persisted for centuries, costing thousands of lives and absolute fortunes.
Okay, let's dive into this. To really wrap our heads around how massive this crisis was, we have to understand that back then, discovering the longitude was viewed as literally impossible. I'm serious, it was a legendary joke. People considered it to be on par with finding the fountain of youth, or, transforming lead into gold. It was mocked so widely that it actually became a running punchline in the popular books of the age. Like in Gulliver's Travels, for example, finding longitude is lumped right in with discovering perpetual motion or a magical universal medicine. It was just a fantastical pipe dream.
So you might be wondering, without a reliable way to find longitude, how on earth did sea captains in the age of exploration actually get around? Well, running on a mix of sheer bravery and, frankly, greed, they relied on this incredibly crude method called dead reckoning. Imagine this. A captain would literally throw a wooden log tied to a knotted cord overboard and then just watch how quickly the ship moved away from it to guess their speed. They'd factor in a wobbly compass reading, check the time with a literal sandglass, cross their fingers, and guess their longitude. As you can probably imagine, they routinely missed their marks completely. They would sometimes sail around for weeks, searching in vain for the actual continent they were trying to reach.
And getting lost wasn't just a minor inconvenience, it was an absolute nightmare. Because these ships couldn't find their destinations directly, the voyages dragged on endlessly. And all that extra time at sea? It condemned sailors to scurvy. A diet with absolutely no fresh fruit or vegetables caused severe vitamin C deficiency, and the physical toll was just horrifying. We're talking connective tissue deteriorating, blood vessels leaking and causing massive bruising, swollen legs, and spontaneous hemorrhaging. Ultimately, it was a slow, agonizing death sentence, all just because a ship couldn't figure out where it was on a map.
But beyond that staggering human suffering, this ignorance of longitude was also wreaking havoc on the global economy. See, because navigators could only figure out their latitude, which is their north-south position, they were forced to follow the exact same predictable shipping lanes. Whaling ships, merchant ships, heavily armed warships, they all clustered together on these few well-trafficked routes. And you know who absolutely loved that? Pirates. These narrow lanes became literal pirate funnels, making heavily laden ships incredibly easy targets. The global economy was just bleeding capital.
Section 1. The Rules of the Game. The Geographic Grid. And this brilliantly illustrates the spatial coordinate system those early navigators were so desperately trying to master. What we have here is a spherical coordinate system made up of intersecting lines. An accurate use of this grid is absolutely fundamental to the science of geography. Instead of the flat, rectangular distances you'd use on a local street map, these global coordinates are actually given as angles.
Let's quickly define the two crucial terms here, just so we have them firmly anchored. Latitude lines, which are also called parallels, measure the angles north and south of the equator. They go from 0 degrees right at the equator up to 90 degrees at the poles. Simple enough, right? Then we have longitude lines, or meridians. These are the angles east or west from the prime meridian, ranging from 0 out to 180 degrees. Now, latitude was actually pretty easy for early sailors to figure out just by looking at the sun and stars. But that second one, longitude, that tricky east-west measurement, that was the deadly missing puzzle piece.
Section 2. The 20,000-pound crisis. The longitude problem.
Let's head back to the 18th century and look at how the government finally stepped in to stop the bleeding. Spurred into action by a string of absolute naval catastrophes, the British Parliament passed the famous Longitude Act in the summer of 1714. And they didn't mess around. They offered a massive prize of £20,000 to anyone who could find a ship's exact longitude within 30 nautical miles. To put that into perspective for us today, that is roughly $12 million. This sheer desperation led to the creation of the Board of Longitude, a blue-ribbon panel of top scientists and admirals. It essentially functioned as the world's very first official government R&D agency.
So the crucial point is that this enormous bounty set up the ultimate underdog story. By the mid-18th century, this high-stakes race basically came down to two wildly different contenders. In one corner, you had the entire elite scientific establishment of Europe. We're talking absolute legends like Sir Isaac Newton and Edmund Halley. They were fully convinced the answer lay up in the stars, using a highly complex system called lunar distances. But then, in the other corner, you had a total outsider, a lone, self-taught English clockmaker named John Harrison, who proposed what literally everyone else thought was impossible, using a mechanical watch.
Section 3. Harrison's Chronometer.
Harrison believed the secret was actually incredibly simple. Just keep accurate home port time aboard your ship while you sail. Sounds easy, right? Well, even Isaac Newton had strongly claimed that no clock could ever keep accurate time on a rocking, violently shifting ship. But Harrison's engineering? It was absolute genius. He built these mechanical masterpieces that were virtually friction-free. They required zero lubrication, which brilliantly eliminated the messy horological oils of the time that would gum up and ruin clock rates whenever the temperature changed. He threw out the pendulum completely, because obviously that's a terrible liability on a rolling ocean deck. He even combined different types of metals inside the works so that when one part expanded in the tropical heat, the other metal would counteract it, keeping the ticking perfectly, flawlessly constant.
And here's the amazing part. Despite having absolutely no formal education, Harrison's highly practical mechanical tool actually worked. But as you might expect, the scientific elite did not want to hand over a massive fortune to some uneducated clockmaker. So Harrison faced 40 grueling years of political intrigue, international warfare, and just bitter academic backbiting. But he didn't give up. Through a series of incredibly tense sea trials, he ultimately proved his chronometer was wildly superior to the unwieldy, completely error-prone lunar method the astronomers were pushing.
When Harrison passed away in 1776, he basically held martyr status, but he had single-handedly ignited a massive chronometer boom. Legions of new watchmakers sprang up to supply the world's maritime nations. In fact, these clocks became so ridiculously essential that when the famous surveying ship HMS Beagle set out in 1831, yes, the exact same voyage that introduced a young Charles Darwin to the Galapagos Islands, the ship didn't just carry one chronometer. They packed a massive stockpile of 22 marine timekeepers just to ensure absolute, unbreakable precision.
Section 4. Mapping Time. Time zones and meridians.
Let's move to and see how this builds into the system we use today. How exactly does carrying a highly accurate pocket watch on a ship tell you where you are on the geographic grid? Well, the math is incredibly elegant. Navigators would simply compare the local time on the ship, which they'd find just by looking at the sun, with the true time back home, which they read right off Harrison's clock. Since the Earth is a sphere, it's 360 degrees in circumference, and because it takes exactly 24 hours for the Earth to make one full rotation, you just divide 360 by 24. So this means every 1 hour time difference between your ship and your home port equals exactly 15 degrees of longitude.
Now, what's really interesting about this slide is how Harrison's brilliant solution translates directly to the modern world we live in right now. Our modern time zones are all completely based on longitude and the speed of the Earth's rotation. The prime meridian runs right through Greenwich, making it GMT or Greenwich Mean Time. Time zones are standardized relative to this exact meridian, essentially slicing the global map into 15-degree longitude chunks that perfectly correspond to 1 hour shifts in time. So the geographic grid and time itself are perfectly, permanently linked.
And just a quick, fascinating physical note on how this actually maps to reality. Once you know your degrees of longitude, you can translate that directly into physical miles. Right at the Earth's equator, where the planet is at its widest, that 15 degrees of longitude stretches out to a full 1,000 miles. Think about that. Every single degree of longitude equals exactly 4 minutes of time, no matter where you are on the globe. But physically, that degree shrinks from 68 miles wide at the equator down to virtually zero as all those meridian lines pinch together right at the north and south poles.
So to wrap things up, the story of finding longitude is just a phenomenal testament to human ingenuity. A total outsider with zero formal training tackled a problem that the absolute greatest minds of the era deemed literally impossible. By building the perfect clock, John Harrison mapped our world, he saved countless thousands of sailors from scurvy and shipwreck, and he totally secured international trade. It really makes you wonder, as you look at the challenges we face today, what impossible problem of our modern age is just waiting for an outsider to look at it from a completely different angle and build the right clock? Thank you so much for joining me on this explainer, and I absolutely cannot wait to explore our next fascinating topic together.